Okay, so in front of us we have a GTX 1080. This is the superclocked by EVGA. But before we begin, I should note that my customer has actually sent a bit of a letter for us to read. So he says that the card has no display, 99 out of 100 boots, and 1 out of 100 boots it works perfectly and runs stress tests and works continuously for a week without issue, up until of course he tries to reboot it. So that's our first hint. If you come across my channel looking for a repair request, I should note that I now have a Discord with a repair request section and the contact details of our graphics card repair experts living in the US, UK, Germany, and Indonesia. So unlike the broken cards that we normally get, we're actually going to see what this looks like by just turning it on. So we're not going to start with resistance and voltage check. Instead, we're just, like I said, going to boot the card. So as you can see, the fans do start spinning, so that suggests that we have 1.8 volts. And if we look at the monitor, so there's those two beeps. In fact, I think it's best if I lift this. So if you look at the monitor light, it's orange, and as you can see, it just turned white, which means that the backlight of the monitor itself is actually on. So anyways, you'll notice that the monitor screen is blank, but the backlight is on. So traditionally this would suggest memory problems, and it might be a memory related error, but because the card is detected, let's just, instead of let's say taking it apart, let's actually try to boot into Windows first and use as much software as possible to make a diagnosis. Okay, so since the GTX 1080 can be detected, we want to be using as much software as possible to help us with our diagnosis. But because the card cannot display an image, we can't actually rely on, let's say, the monitor itself to display an image unless we hook up our GTX 1080 as a secondary graphics card. Now, I know that some of my viewers don't have spare graphics cards or even integrated graphics, so what we're going to do instead is we're going to use a program called TeamViewer to remote desktop into my test bench, I should say. So we're just going to double click on G970A, which is my test system, Gigabyte 970A. So now that, okay, this is the, what you see here is actually the desktop for the test bench, despite the fact that the GTX 1080 can't display anything. So what we're going to do is we're first going to go to Device Manager. Now, Device Manager is a little bit useful in that it can show you if you have, let's say, any codes or error codes. So in this case, we have an error code, or code 43. Code 43 is a rather famous error code. In particular, it generally relates to either the BIOS or the memory, but is not necessarily caused by either. Now, the next piece of software we're going to use is GPU-Z. GPU-Z is very useful in my opinion. In fact, it's my favorite piece of software for diagnostic work, and that's because of two particular fields. So, well, one particular field, but we're going to go over the second one first. So the first thing you notice is that the default clock for GPU clock and the memory is 0 megahertz, and the memory size is 0 megabytes. This is these fields here are not particularly useful. So a lot of people always will complain to me that they have 0 megahertz on again, let's say the memory clock. This is not really that useful as a field, and that's because what happens is that if the drivers fail to load, this will show 0 megahertz, and that doesn't really tell me anything. The field that you actually want to be paying attention to is actually the BIOS version. Now, what makes the BIOS version relatively unique in comparison to, say, other fields is the fact that the BIOS version can't be pulled from let's say, some internet database or from the GPU die itself. The BIOS version has to be read from the actual BIOS chip itself. So the fact that this particular card cannot read its own BIOS version suggests to me that we have a BIOS-related error, and that is our actual cause of code 43. In particular, the primary suspects are the BIOS chip itself, the firmware in the BIOS chip, the BIOS resistors, and lastly, and most importantly, the GPU itself. Okay, so as you saw, the card has code 43, and because we have a BIOS version that cannot be read, our suspect is of course the BIOS chip and the BIOS resistors. The other possible cause is that we have a dead GPU. So if you don't know, the motherboard cannot actually it cannot access the BIOS chip, or it cannot read from and write to the BIOS chip directly. Instead, it has to do so through the GPU itself. And since the GPU sits between the BIOS chip and the motherboard, a faulty GPU can cause the motherboard to not be able to read the BIOS version off of your graphics card. Since we do have code 43, the two main power rails that we want to check are of course 1.8 volts, and we also want to check the memory just in case we have a memory related error. So starting with the memory, 114, that's a very high number, that's fine. And now checking 1.8 volts, we should see about 900 for GTX 1080, 880 ohms, perfectly fine. There's no problem with the 1.8 volt rail, and there's no problem with the memory, so that suggests of course that we have a good or living GPU, but just checking the PEX rail just in case. Yep, 110 ohms, perfectly fine. Okay, so since we have a likely BIOS related error, and I don't have any efficient method of determining what exact component is bad. So what I'm gonna do is I'm just gonna replace the BIOS chip itself, and of course flash the new one, and then we're gonna see if the card boots. Okay, so as you saw, I replaced the BIOS chip just from another GTX 1080. Let's go ahead and boot the card. And as you can see, we have a BIOS splash screen. So it worked on first boot, but you may remember that the owner said that the card only displayed an image, maybe once out of every 100 times. So let's go ahead and boot it 2 or 3 more times just to confirm it does seem to be in better condition. Okay, booting it again. Okay, that's 2 out of 2. Let's try again. Okay, that's 3 out of 3. And that's 4 out of 4. Yep. And that's 5 out of 5. Yep, okay. So I think the problem is likely solved. So let's go ahead and put the card back together and stress test it. So as you can see, the card runs. It works just fine, as you can imagine. So there's 2 things I want to discuss before we end the video. The first is a question that a lot of you might have. So I'm sure a lot of you are wondering, how did I know, for example, that it was the BIOS chip and not just the actual BIOS firmware? It's given that I changed both at the same time. So the giveaway is actually in the customer's hands. So you may remember the customer said that the card worked properly once out of every 100 boots, but didn't work the other 99 times. So I can actually confirm this. I saw the card boot with an image and work properly exactly once, and every other time it failed. So the reason why this tells us that this is the BIOS chip itself and not the firmware is because if the firmware was faulty, it would fail to display 100 out of 100 times. And if the firmware was good and everything else was good, it would display properly 100, it would work 100 out of 100 times. So the fact that it's intermittently faulty suggests to us that the firmware itself must be good, but the BIOS chip is failing to properly send out the information that the motherboard needs so that the motherboard knows how to interact with the actual graphics card itself. And that's also why it works, for, let's say, a whole week when it does actually work properly. Because the motherboard only has to read from the BIOS chip once when the motherboard first posts, and then after that, the graphics card, BIOS chip can go back to being faulty because it's never needed again. Okay, so the second and last thing I want to discuss before we end the video is actually the fact that this card, when it was faulty, it couldn't display an image, but the backlight of the monitor turned on. So for those of you who watch my channel on a semi-regular basis, this often implies that we have, let's say, a faulty memory bank or just memory corruption in general. I should note that this is not always the case. The one odd thing about BIOS errors is that BIOS errors can often mask themselves as memory errors. In particular, if we look at, let's say, the hold on, let me just pause this. Like I was saying, if we look at the match report for this card before it was fixed, you'll notice that the read errors are, there's quite a lot of read errors, which is 20 megabytes, and in particular, it's actually the maximum number of errors possible and it's on all banks. So, like I said earlier, a lot of people who have, let's say, cards with BIOS errors or BIOS-related errors, they'll often run mats on their cards, and they'll often end up thinking that they have some catastrophic, memory controller failure, when in reality there's often something else going on. Whenever I see this, if you see something like this, you shouldn't assume that it's a dead memory controller. It could still be a dead core, but not necessarily a dead memory controller. Generally speaking, when you see stuff like this, it's just inconclusive because there's something else going on. And in this case, it was due to a faulty BIOS chip, mostly faulty, but sometimes working BIOS chip. Just as a bit of just so you can see, the errors themselves, they have the form bad or ACB, not, or the last 2 change, but it tells with bad, and it's obviously very bad. But anyways, if I hope you learned something watching this video. If my channel has helped you out, consider becoming a patron. Links in the description. Otherwise, hopefully I'll see you in the next one.